When solving equations with variables on both sides, every once in a while we run into some problems that might confuse us. So I want to show you a couple examples. Let's focus here on this first one. We have 4 times the quantity x minus 5 equals 4x minus 20. Again, it's not a bad idea if we're going to simplify each side to go keep, change, change, and change our subtraction, keep, change, change, into addition. You don't have to do that for this problem, but like I said, it's not a bad idea. Then we apply our distributive property, because when we're simplifying each side, we don't want to have parentheses, so we're going to distribute the 4 to the x, and that becomes a 4x, plus 4 times the negative 5 is going to be a negative 20. Over here, there's nothing to simplify, so that ends up being 4x plus, and I'm going to put the negative 20 in parentheses. Now, ladies and gentlemen, when you look at this problem right here, okay, you should notice that, well, they're basically exactly the same. You know, if you wanted to and you'd subtract 4x off of each side, they'd cancel out and you'd be left with negative 20 equals, well, negative 20. That's a true statement. In fact, 4x plus the negative 20 equals 4x plus negative 20 is a true statement. There is nothing you can put in for x into this original equation here where you won't get both sides are equal to each other. It's an identity. They're the same thing. What I mean is, oops, if you look at our original equation here, you could take whatever you wanted for x and plug it in. So if I did 8, 4 times the quantity 8 minus 5, does that equal 4 times 8 minus 20? Well, 4 times 8 minus 5 is 3. 4 times 8 is 32 minus 20. Oh, notice we get 12 equals 12. And that's going to be true for anything because they're exactly the same. So in this case, what you get whenever you get two sides that are exactly equal is you'd say that there are, well, what I would say is all real numbers are solutions. So what is the solution? All real numbers. Okay, and again, a cool way we can write that, or I think it's cool anyway, is you do a double bar and make an R. Okay, so you could write out all real numbers are solutions, or you could make this capital R with the extra bar here. Because whatever number you want, you can put in for x, and it's going to make this equation true. Now if you look at this one here, okay, in this case, again, we don't necessarily in this case have to simplify, but if you want to go keep, change, change, and make that a negative 9, that's a good idea. Now, let's get rid of this 3x. How do you get rid of it? Well, you subtract it from each side. Again, I'm just using our normal solving techniques. 3x's take away 3x's, well, that cancels. I'm left with a negative 9 equals, well, 3x's take away 3x's, that cancels. I'm left with 10. It does negative 9 equal 10? No. Okay, that's not a true statement. And what that means is when you get two things that, well, they just can't equal each other, it means that this side can never equal this side. So in this case, we'd write for an answer, no solutions. Because there is no x value that you can substitute in to make these two sides equal to each other. So when you're coming across problems, if you ever get something where, well, both sides end up being exactly the same, or you get something where it's just not possible, you have two answers you can put. All real numbers or no solutions.